Another thing we need to look at when looking at our trig values of any angle is what is called the unit circle. And in the unit circle, the radius, or that r value, is always going to equal 1. And then the center of the circle is always going to be at 0, 0. But that just kind of simplifies things a little bit because that r, we don't have a value then for that r. The r is always going to be 1, which means then any point on the unit circle will always be the cosine, comma, the sine. So the x value will be your cosine value. The y value would be your y value will be the sine value. So x and cosine go together, y and sine go together. So if you've got unit circle, so radius of 1, and you know the point, then you can figure out the cosine and the sine very easy because it's just the x value and the y value. The second part of today's lesson looks at what are called reference angles. And these are positive acute angles, and we represent it by this theta prime, so a theta with a little mark above it, formed by the terminal side of theta and the x-axis. Now remember, we will be going to the closest part of the x-axis in order to make it an acute angle. So keep in mind that it does always have to be positive and acute. So those are two key things with your reference angles. You've got to make sure that we have positive acute angles or a positive angle and an acute angle. So when looking at these, our angles can be in any of the 4 quadrants. So if we look at it in quadrant 1, our reference, so there's our angle there. Our reference angle is also that angle. So when finding the reference angle, your angle is going to equal your reference angle when in quadrant 1. If we look at quadrant 2, so we put our angle over in quadrant 2, this is our angle, but our reference angle, remember, has to be an acute angle, and it's from the terminal side of our angle to the x-axis. So this angle here is going to be our reference angle. Oops. So that angle there. So our reference angle is going to equal 180 degrees minus that angle. Or if we're working in radians, the reference angle is going to equal 180 is the same thing as pi, so pi minus our original angle. So that's the second quadrant. So now let's look at it in the third quadrant. So if we're in the third quadrant, my angle's down here, which means that this is my original angle. So then my reference angle goes back to the x-axis, and we want it to be acute, so we go to that closest side. We don't want to go to the other side because that would make it an obtuse angle. So we go right there to that closest side of the x-axis, and that's my reference angle. So then my reference angle is going to equal the original angle minus 180 degrees. Or in radians, the reference angle is the original angle minus pi. And now one more quadrant, so let's look at it in the fourth quadrant. So in quadrant 4, our angle would be over here. So my original angle would be this angle. So then my reference angle would be this angle. So to find the reference angle in the fourth quadrant, it's going to equal 360, which would make that full rotation, degrees minus the original angle, or in radians, 2 pi minus the angle. So depending on which quadrant you're in will depend on how you find that reference angle. Now all of these that I just did were for positive angles because we started from the initial side and went counterclockwise. So now it's a little bit different if you work with negative angles, but most of the angles we look at are positive, so that's why we break it down into each quadrant for the positive angles. But always remember that your reference angle has to be positive and acute. So now let's look at a couple examples of finding these reference angles. So example 2 says find the reference angle theta prime for the given angle. So if they give us that our angle is 210, first thing you need to do is figure out which quadrant it's in. So 210 would be over in the third quadrant because it is more than 180 but less than 210. So here's my original angle. So then in the third quadrant, our reference angle, going back up to that x-axis, would be right there. So remember what we just talked about in the third quadrant. I'm going to take, to find my reference angle, I'm going to take my original angle and I'm going to subtract off 180. And when I do that, I get 30 degrees. And there's my reference angle. Notice that it is positive and it is acute. So now let's look at maybe when our original angle they give us in radians. So 7 pi over 12 is going to be my original angle. So again, the first thing you need to do is figure out which quadrant it's in. So my 7 pi over 12, if I think of it in terms of just that fraction, 7 over 12 is a little over a half. So I know that half of a pi is where my 90 is, or straight up. So here my angle would be there. So there is my original angle. So the reference angle would be this angle. So it's in the second quadrant. So in the second quadrant, when I'm working in radians, I take the angle minus pi. Oh, sorry, the other way. Pi minus the angle, because pi is bigger. Sorry about that. So pi minus 7 pi over 12. I gotta make a common denominator, so 12 pi over 12 minus 7 pi over 12 gives us 5 pi over 12. Let's look at one last example where your theta is a negative, so negative 295 degrees. So when we find that, so go ahead and draw that out. I know that when I draw a negative, I've got to go clockwise, so I start coming down from the initial side. And then when I do that, negative 295 would end then in that first quadrant. So then to find that reference angle, I would need to take 360, because that would be one full rotation, so it's not quite one full rotation, minus that 295. And notice I'm just doing 295, not a negative 295, because if I end up doing minus a negative, that would add, and I get a huge answer. And remember, this has to be acute, so it has to be less than 90. So when I subtract those two, I get 65 degrees, and there is my reference angle. Another thing we need to look at is when we start doing our trig values of these reference angles, we need to know what values our sine, cosine, and tangent have in each of the quadrants. So it's important for you to know these values. So I've drawn here the coordinate plane, and in the first quadrant, all three of our trig values are positive. Now keep in mind, we can extend that to the 6 because the other three are just the reciprocals, so they're going to follow the same sign as what their reciprocal function. So the cosecant will always be the same as the sine, the secant will always be the same as the cosine, and the cotangent will always be the same as the tangent. So in the first quadrant, all of them are positive. In the second quadrant, the sine is positive, but the cosine and the tangent are negative. In the third quadrant, the sine is negative, the cosine is negative, but the tangent is positive. And in the fourth quadrant, the cosine is the positive one, with your sine and your tangent being negative. So an easy way to help us remember this is by looking at the first initial of the one that is positive. So in the first quadrant, that's A. The second quadrant, that's an S. The third quadrant, that's a T. And in the fourth quadrant, that's a C. And the nice little saying that we like to use is all students take calc. So if you remember that, that'll help you remember which ones are positive. Just remember the first letter of each word represents which one is your positive trig value in that quadrant. So now when evaluating our trigonometric functions using our reference angle, there's 3 steps. The first thing you need to do is find that reference angle. So find theta prime. The second, now that you know your reference angle, is just to evaluate the trig function for theta. So find the value, find your trig function for that reference angle. And then after you've found your trig value for the reference angle, you're going to determine the sign being either positive or negative for whichever quadrant theta lies in. So remember, you look back at your original angle, determine which quadrant it would be in, and go off of that using what we just talked about with the all students take calc. So now let's look at a couple examples of finding our trig values or trig functions using reference angles. So when given the sine of 240 degrees, we want to find the value of that. Now remember back when in the first section, we only knew the sine, the cosine, and the tangent values for angles like 30, 60, and 45. So remembering back to section 9.1, I just put up here in the corner that little chart that I gave you for the 30, the 45, and the 60, because we will be referencing that as we use our reference angles to find the trig values. So if I wanted to find the sine of 240 degrees, that's not on this chart. It's only the 30, the 45, and the 60. So I need to use my reference angle so that I can find that exact value of the sine of 240. So the first thing I do is find the reference angle. So let's find the reference angle. So 240 would be in the third quadrant. So this is 240. So my reference angle then is going to be this angle here. So I'm going to take the 240 and I'm going to subtract off 180. When I do that, I get 60 degrees. So now that I know my reference angle, the next step was to evaluate the trig function at that reference angle. So in this case, I'm going to do the sine of 60 degrees. Now that is in this chart, so if I look up at the chart, I go across the first row down to the last number there, so that would be the sine of 60, and that tells me that it is the square root of 3 over 2. The last thing I need to do is look at my quadrants. So since this is in the third quadrant, if I do all students take calc, in my third quadrant, only the tangent is positive. Since I'm working with the sine, that tells me that my answer needs to be negative. So it would be a negative square root of 3 over 2. And that is my answer. So now let's look at another example. Let's say that I want to find the sine. Now let's do cosine this time. Cosine of negative 225 degrees. So again, the first thing you're going to do is find that reference angle. So negative 225, meaning I go down from the positive part of the x-axis, 225 degrees. So that puts me over here in the second quadrant. So there would be my negative 225. My reference angle then is this angle here. So I am going to do the 225, and I'm going to subtract off 180 because I know I want a full 180 degrees. So when I do that, I get 45. Now remember, reference angles are always positive, so that means that this is going to be a positive 45 for my reference angle. And then so that was the first step. Second step is to evaluate the trig function at that angle. So the cosine of 45 degrees. I look at my chart that I put up there in the top corner. I go across cosine till I get to 45, and I see that it is the square root of 2 over 2. And now again, I look at, third step is figuring out the sign, positive or negative. So I go all students take calc. In the second quadrant, sine is the only one that's positive. So that means cosine has to be negative, so my answer is going to be a negative square root of 2 over 2. And there is my answer. And let's look at one more that works in our radians. So C, and also let's do a cotangent, so one of those reciprocal functions. So cotangent of 5 pi over 3. So first step is to find that reference angle. So 5 pi over 3, I know is more than half a pi. It's more than a pi. It's actually also more than 1.5 pi's. So that means that it's going to be in that fourth quadrant. So there's my angle. So then my reference angle would be this angle here, which means I need to take 2 pi, since it's in the fourth quadrant, minus the angle, so 5 pi over 3. So find a common denominator, so 6 pi over 3 minus 5 pi over 3 gives me pi thirds. And now I need to evaluate the cotangent of pi thirds. But cotangent's not on my chart, so remember to find those reciprocal functions. I first find the reciprocal function, which in this case is going to be tangent, and then I just flip it over, or I can think of it as 1 over the tangent of that angle. Well, tangent of pi thirds is on my chart in this case. Well, we got to think of what these, I have the 30, the 45, and the 60. Remember that 30 is the same thing as, it's kind of hard to see up there, let me change the color. So pi over 6, 45 is the same thing as pi over 4, and 60 is the same thing as pi over 3. So when I'm talking pi over 3 in this problem, I'm talking the same thing as a 60. So the tangent of pi thirds, or the tangent of 60, is the square root of 3. So this is going to equal 1 over the square root of 3. But I can't leave a square root in the denominator, so I multiply top and bottom by the square root of 3. So I get the square root of 3 over 3. One last thing, remember to check our signs. So all students take calc. In the fourth quadrant, cosine is the only positive one, so this one again would have to be negative, so it's a negative square root of 3 over 3. So remember, when evaluating your trig functions, you're always first finding the reference angle, then evaluating your trig function at the reference angle, and then always make sure you're looking at which quadrant you're in to figure out what your sign is, whether it's positive or negative. So you got to make sure you get that right sign on there.